Hello and welcome. The first thing we're going to do is using some naming conventions and then some of cleanup as well. So firstly, we just want to make this separated into some function. So that's pretty simple. It's just called once in the whole script of ours. And it's defined right here. So we cannot call this one by one. We have to call it every frame. So I'm just going to define a function for this. And it'll player UI, and all it does is whatever is required for the player UI, it's just going to send in there. So this one. Next, we can go here into the camera area. And everything else you can see it's pretty alright. So I guess it is almost time to start using the naming conventions. So let me just give you the rules. For any private variable which has private as its identifier or its local or globalness, you can just set it like that, so underscore before it. Anyway, let's just fix this as well, make it look more neater. So to start by naming conventions, it rename it. Make sure to take screenshots of all the player controller settings before continuing so that you can set them all again. So go in your inspector and take all the screenshots you want. So now just do Command R on all of the private variables and add an underscore before their names. For the public ones, they have to be having capital first letter. That's it. So let's do that. As you can see, I'm just going to add an underscore to all of these fields I have made that are private. And finally, that has finished Boolean. Then we have the animator variables. We have the gravity jump. So I've sped up the process as it's pretty slow. So I did all the fields actually. I didn't show you all of them though. But I have set all my fields back as well. As you can see, we also had some useless ones. I'm just going to delete those out. Some constraints that were actually old, not used anymore. Now, if you want to really have a look at my one, you can just have a look at those. So I'm just going to go zooming past all the fields I made. You've got the ground lay mask, the gun holder I made it, and the curve that we made. I had to redo it though. We have the looking amounts. Then I have the camera reference, and actually we can remove this as it's useless. I'm gonna compile after a while. So then you have this actually, yeah, the kind IK followers, and then these clip prevention settings, and then everything else. So just gonna compile that out. Now we can do the same for our player UI script. It just has prime fields, so just make them all have an underscore. Now just find the correct fields for this. I'll assign them manually as I didn't take any screenshots, but thankfully the names are pretty similar, so we can get exactly what we want. Now this bullet decal object is used everywhere, and we're going to be losing the references that we assign to it. For the barrels, let's just create an empty, actually not, yeah, don't create an empty. Just gonna rename all of these and give them the underscores. Let's save and come out. And now you'll see that we don't have any references assigned. So let's assign them one by one. The groups are actually the same, so just assign the stone effect to them. Now I'm just gonna assign the wood to the barrels actually. Then for the cubes, we can give them some other one, maybe the metal impact on them. Yeah, anyway, doing testing, this playground isn't really any games playground, it's just for having some testing around. So we'll use the slab and assign the uniform parent. And as you can see, I think we have assigned all of these. However, there are still the slopes in the walls left. Well, in that, we're just going to pass in the bullet impact stone effect, and that should do it for us. Now, in the player model, I'm going to show you a technique which sometimes works and sometimes doesn't work. It is to use the formerly serialized as attribute and then give it the old name and then add the underscore. So, well, sometimes it does work, but a lot of times it doesn't work. So now when you delete it, it usually loses the reference, but sometimes it does work. So if it does work for you, then you can keep using it. But sometimes it doesn't work, so I plan not to use it later on. I'm just going to be making duplicate fields and then looking at those, or screenshots is the best, I guess. So anyway, for the animator, then we can also remove the rest of the audio clips and everything. And the mag holding pause is actually no longer needed. This in out and everything else, it's useless. Okay, so I noticed the mag holding pause is not needed anymore. We just removed in the whole player model and the commented code that we did, and also that using statement. Now I'm going to actually use the serialization thingy and hope that might work. So I'm just going to use that. I'm going to use the formerly serialized as attribute. I'll rename it to the actual name that I want. And then the private ones, you don't need to do anything with them, just rename them directly because they are assigned by default. And then add them to the rest of the fields so that we can rename those as well. Now for the fields, I'm just going to also give them their names. So I'll give them the attribute assignment first and then rename them. Alright, that's done. We'll save and get out. Now right here we can see all our settings have not gone anywhere, and we can now remove those attributes. So hopefully we will not lose our values, and it should work. Sometimes it works and sometimes it doesn't work. So we'll define a private transform for this transform in underscores, yes, the beginning. And then at the beginning, we'll initialize this in the await function and assign this transform to this actual transform. And now, wherever we're using the transform of this object, we'll replace it without this transform. So I'm going to do that for everywhere. As you can see, it's used here. Just going to do that right there. Right here as well. Here also, there as well. We're using the transform rotation. We'll get passing out this transform and here as well. So we're getting an error because this was not our own transform anyway. Yep, that's not ours. It's all the other transforms we're accessing from some other objects. Alright, so I guess we're done, maybe. Let's have a look at how much more you'll find. I've used Command F or Control F to actually find. As you can see, we just have two more areas where we need to change this in the on-row gizmos. So first I'm going to check if it's not equal to null. If it's not equal to null, then only we want to actually, well, use this transform. But I'm going to assign the ground check position to 0 by default, so that we can actually not get the issue of not assigned. Similarly, I'll do this for this one as well. Check if it's null. That's it. So I guess this transform is just a cached reference of the actual transform. So hopefully everything else will work just like it was. Yep. Movement is getting the correct angles. We use the transform to get the right and the forward for our movement. So everything is working. Now what we can do is the next thing. Let's just close everything out. And the next thing we need to do is remove the new keyword from everywhere, and of course some cleanup that we might find on our way. New keyword from loops is especially good to remove. So I'm going to actually cache vector 3 as the camera holder or rotation. And then instead of doing this, we're just going to assign that. Now we're going to have to assign each vector separately because we don't want to do the new keyword again. Just like that. And that one's different, so just assign that in there. Now we're getting an error because, yeah, we need to add an underscore so that the naming is correct. Let's find any more news. Yes, in the ground check position calculation. So for here, we'll define a ground check position again as a field instead, and then assign it to the position. Then just change the y vector to the ground check distance plus whatever our actual transform was, and use that in our checks still. For the trigger weapon impulse again, you'll have to use a field. You can use jump bump mount, right? And then use it here. So set that directly first with on the x-axis to 0. Alright, so just assign it by default to 0 so that you don't have to change that at all. Just give in the jump amount back and assign that to the jump amount, the y-axis. Trigger the impulse with the correct fields. Now, for this one, you have to repeat the process. So we'll again be assigning the fields. So I think we can just use one of these and call it the bump amount, right? And then reuse it in the same place where we have to perform this one now, right? That way we don't have to have two of these where we don't need those two. So now I'm finding the new keyword and we have found it right here where we assign the center of the controller. So I'll define a center as the controller center and assign it to 0 by default. Comment it all out, and then I'm going to simply assign this center at the y-axis, this to the ground center y, and then use that center directly to lerp. Now this is proning, so we'll use a prone center y, and this one right here. That's it. Now for this one, these sphere checks that we use to push our guy off the ledge, we will have to remove the new again. So we're just going to define a field for this. Yes, similarly, just assign the y-axis of this directly to the y-offset. And just to simplify things, I'm going to, instead of comparing directly to true and false, just use the shortcuts, which is not and nothing. Again, we have a new, so we'll use this by notation target instead in the look function. Then we'll assign each of the axes that we need to assign manually. And then reuse it in this area. So the last one needs both of these. The second last one needs vector 3.0 and then one of these. Now for this one here, right here, we'll have to define a new vector, which is the z-axis only, and just assign it only the z-axis of this to the z. That way we have a vector which only has the z-axis, and we can use it. Right, so new is I think that should be quite a lot of use. Well, right here we can see we are again using it. I'm going to change this by making two new fields. One for the spine constraint offset. Actually, one was enough, I guess. Just assigning the constraints to that. Constraint offset, actually. So both of them can be assigned. And then actually assign the actual variable, which will then give us some values. We'll assign the x of this component and the z-axis. I think the y and the z. So z to 0 and the y to alert to the spine constraint offset y. And we'll just do the same thing on this side, but with different values. So for this one, it uses x. The difference is not volt, but it's there. I'm just gonna replace it with the correct axis. All right, and then 0 at the end. And then more news, and then that's it. Just have new keywords here, 4 of them. Just going to be fixing this as well. I'll use the ground check position directly, which is a field already made for us. We made this, so we don't need any of this, I guess. But if the ground check is equal to 0, then we'll assign ourselves. We'll assign all of these completely in the on gizmos. And then similarly for the ground offset check thingy or the G offset vector, we'll check if it is 0 and then assign accordingly. Okay, let's give it a test. Actually, before I do that, I noticed some issues. So let's find the G-sphere thing and find no references on it. So right here, I was assigning it to the offset, which is actually incorrect. We need to assign to the actual vector to, I think, the transfer position, then plus equals the offset so that we get the correct y-axis. Similarly for the ground check on the on gizmos and also over here. Just to make it simpler, I will use plus equals as well. Now we are ready to give it, I think, a try, maybe, unless we find more bugs. Now I'm going to find the center, as that also has some issues. So as you can see, the height is assigned correctly, but we're using the standing height instead of the standing center-wise. So let's fix that. All right, that's done. Now let's use it and have a look. So everything seems just like all right. And I can move around. The ground check is working. We're not flying in the air. So I'm just going to give a quick test. As you can see, I'm going around. All right, now just to put all these fields, this is what you need to do. Just put them in their correct sections yourself. So that's what I'm going to do next. So now the next thing we do is actually camera cleanup and radius changing face. So if I hit play, we actually have a bug due to the things we have changed. For some reason, the radius just keeps on changing crazily. So we can fix this. It is to fix this issue that we did here. Just assign the G-sphere not with a plus. Only the vector that we created ourselves. I did not actually change that and forgot about it. Now I'm just going to clean up the camera code. Right here you can see I'm going to simplify these ifs. And I'll only assign the target position. and directly to the aiming and normals and the correct clipped ones as well. We don't need these transforms that are created anymore, as they not required anymore to us. And then right here, just assign the local rotation directly to the camera rotation, and equal this to the actual thing. Don't multiply it, because then you will get the wrong thing, which is 0. So the leading and everything that's worked. Next we do the movement, cleanup, and calling move only once. Currently our controller calls move twice, which is not a very good thing, especially for optimization. And of course it's a cleaner thing to do, it's just call it once. Now we're gonna fix that. Let's do this very simple. Let's come over here and let's just make our system in a bit of sections in the handle input and move, because I'm gonna actually put the jumping and everything in one function because that's pretty simple code. So I'm going to comment out the one which uses velocity y, and I'm going to assign the move direction directly to the current speed multiplied, and then I'm going to assign the y to the velocity y. That way, you don't have to actually do another call of the move and then assign the y-axis with the up, because the move direction will encounter for that by default. Okay, now I'm going to put the gravity code in there. There you are. And the jump code, which is right here, big chunk of code. And comment out the actual function, both of them, gravity and jump. So I guess this code is pretty clean, and we're gonna now have to remove the code that was, well, actually I'm gonna call this a different area. This is the air state management, because that's more like the ground check area actually. Now what about actually assigning, actually that wouldn't be better. I think we can just continue with the velocity y instead, just to keep things simpler, and nobody will have to actually move direction.y to get the y velocity. Just use the y velocity variable. Which one's better? Let me just have a think. Actually just keep it y velocity, the velocity y underscore. Just calc and trigger the impulse effect. I'm just gonna add a few useful comments. And I can go here and just comment that out as well. So we have quite a lot of chunks of code that I just commented out. So as you can see, I can jump just like normal. Movement is all fine. And actually the radius also will work. The radius changing that we already fixed anyway. Alright, so time to clean up player and weapon implementation. So the player and weapon have very, very messy interface where they talk with each other. Players again and again managing a lot of stuff with the weapon, which is not very good. And the weapon should manage most of the things. So let's do that. Let's come over here and look at the shoot function. All this stuff should be done by the weapon itself. Just the triggering of the shooting, because the input is taken by the player, so that's pretty okay. So here you go. We check only in our condition, and all our conditions is clipped because that's what only we should handle. The weapon will have a hard time handling that, so it's okay to keep it with ourselves. So we'll try shooting if we get the input and we're not clipping. So we'll then pass and shoot with the fire point, but actually we don't even need to do that. So just remove the position and the direction. Now I'm going to add a bool, and it's going to be did shoot. So the weapon function is going to tell us if we did shoot or not. And if we did not shoot, then we just get out of here. Then for the direction, just comment that out as well, and all this code as well. The extradition is something we need to do, so we'll keep that there. Now let's go to the weapon base section and make this a bool first. After a while, yeah, let's just do all the code that is here. Firstly, so as you can see, we need to delete the ammo. We need to play effects. We need to play audio clips as well. And make it a bool. So now we need to return some bool. The gunshot timer is also going to be on our own weapon base. And we need a function for the handle shooting as well, so that we can do the gunshot timer updates in the update function. Now we'll do this and just refactor some stuff up and down. And I'm going to return, first I'm going to implement the gunshot timer correctly. Here you go. This is the big long statement we were using earlier. So we'll check if the ammo is less than or equal to 0, or is reloading true, or weapon state is not equal to. So if that's so, then we want to just return. Actually, I'm just updating it so that we only have to return false. And at the end, if we do everything, we return true. All right. Now we also need a is reloading thing in here in our own in our own weapon-based script so that we can use it. Complete demo, add heat and set gunshot timer, play effects, get impulse recoil. If we come here, if we have successfully shot, return true. Now we need this function right here as well because it's really useful, especially for randomizing our direction. They just so here you go. I'm going to use it again. I put this code right here, and this is going to be checking ourselves, and we perform the raycast also ourselves in the weapon-based script. We don't want the player to do this code, as this is something that the weapon should do. So we get the position, and then we also need the direction, which is a vector 3. We give it the direction correctly, if I point it forward, and we get the weapon.max bullet spread angle, which is in the scriptable object that we created to perform the shooting. All right, pretty clean. Also, we can remove this. Now it's time for fixing the reloading issues. So, as you can see, we're using this bool, which we should not be using. The weapon should be keeping handle of that. So we should just check if our weapon is reloading, not have a bool that we have ourselves. So I'm going to also fix that so that we can use the reloading time in our own weapon base. Now our weapon base will handle all the reloading stuff. There you go. And then I'm just going to get that code right here. And then for checking about if we can reload or not. Again, the try reload is just going to check its own function. So if we're not clipping, that means that we're not clipping. And we get the input. And interaction range, we're not in interaction range because, of course, it's something that we must not be in. Otherwise, gamepad will have issues reloading and interacting. So return if the conditions are still all true, or true if any of the conditions meet. Then we do the coroutine starting, we invent the owner start and owner exit stuff. Okay, now we'll be using the current weapons reloading instead, and I'm going to make this public. I'm going to make this a get and read only. We don't want anybody else to be able to assign as is reloading, only the main weapon. Okay, so our code can now use it to check only. Cool, and we also need to check about the timers for reloading and left and IK. That's all. Now right here, we can remove all of this code in a while. So if it is false, we want to return. And right here, I think I made a mistake, maybe. Yeah, the gunshot timer, actually. Okay, I'm almost done with this. So actually, I think I should debug log on some of this stuff. The gunshot timer and the demo and everything else. Let's see what we're getting. Well, so the issue is right here, and we can fix it by thinking again. So if we are reloading, or the current timer is less than or equal to 0, or the timer is greater than 0. So we'll reload and come back here. And as you can see, the reloading issue has been fixed. Cool, so we got it working. We can remove the debugs and everything. Now we can remove this commented code that we did, and we've made it much simpler. The shoot function and the reloading function, pretty simple now. No more complications or checks that the weapon should have done itself. And these ones that have become useless variables, we can just delete those, which have no more use. They're not used anywhere, so just delete them out. So this error is literally just useless. I don't know why it comes. It just sometimes comes and sometimes doesn't. But nobody cares about it. Everything seems to be working fine. So let's move to the next task, which is fixing the shotgun reloading issue. So actually the shotgun is having issues while detecting when to start the reloading. And that's true because before the shotgun would start reloading when everything was correct. Now it has to do the condition check itself. So we'll just get that, start reloading stuff, and we'll pass it in there. Make it a public, again, make it read only because nobody else needs to set the gunshot timer. So now I think our shotgun should work. And it's checking itself about the reloading. So yeah, I think it all works, and it does work. So I'm going to save everything, and yep. Now what we're going to do is move over to the player controller and simplify our weapon clipping code a bit. Make it just a bit more better in looks, I guess. So I'm going to assign the clip projected position again to the local position of its to the projected position. The visual local scale using a short if statement. Assign the correct boxcast clip size so that we can see the visual correctly, and get the clipped state that we'll use a function for that as well, which is weapon clipped. We'll set the spine constraints, we'll assign the clipped state again based on the clipped, and then we'll assign spine 1 constraint data and offsets. So both of the constraints, 1 and 2. Then we'll update the constraints weights. We need to also assign the local position of the weapon to the weapon position offset. Then we need to update weapon transform. So let's actually begin with the isWeaponClipped function, which is a bool. We return its clipped, which we're defining right now, which is a bool, and we assign it directly to a checkbox from the clip projector position, and it has a size of, well, cron weapon data box size, and orientation of clip projected rotation, and the clip check mask. So I'm just going to push this up there. Then if we're not clipped, meaning this one failed to hit, but we are actually clipped, then that means that we need to check with the actual big clip size as well and assign the clipped to that. And I'm just going to divide them both by 2 because I forgot that it wants the extents, not the actual size. So now I'm going to set the spline constraints function, and we'll assign the lerp pos to the method with lerp from the lerp pos to the clipped based on 1 and 0, based on clipped state 1 and 0, and then just multiply it with the speed and at the time. We get the target offset y. Again, we'll check if the clipped state is true, then 0. Otherwise, we want to pass in the spine constraint offset y. Then just assign the constraint offsets, the x and the y component of them, to 0 and target offset y. And then just assign them directly to the spine constraint offset. So the offset 1 and the spine 1 and spine 2 offsets will be assigned to the correctly calculated one. Now we need to update the constraint weight, so we get the IK weight, which is equal to that, based on what the person has selected, IK based or rotation based, and then we just calculate the rotation one with a simple calculation. IK lerp speed, which is 10, and then we just lerp both of these modifiers, weights, do them correctly. Now the last function, which is update weapon transform, we just set the gun holder's local position and rotation using their nice function. And we'll pass in the position, which is lerp from initial to the actual new position based on lerp pass, and then quaternion.lerp again based on new lerp pass to the new rotation. So again, we can now move around. As you can see, everything does work, and we do have clipping working. So there was no issues now. Which is good. So I'm going to remove this big chunk of commented code that we previously wrote, and now this simpler code. Just clean up everything. Now I want to actually make this a list of constraints that are allowed, the rotation constraints. That way we can support as many rotation spines that the guy has made. In my case, I have 3, so I would like to have 3 of these. And it's not a very good thing to have 3 of them, as Derek feels. Just use a list. And then I'm gonna iterate over all of these using a for loop, as you can see, and that many times until we have an I which is not smaller than that anymore. We'll create a new field for this binaration offset, define it at the top here, and remove these two as they're not used anymore. All of them are assigned to just one of them, and we remove that common code as well. So the spine rotation offset dot y, we'll set it to whatever was the first one, from that to the actual target offset, and that's going to be based on the speed. Now we'll use that function and remove that code that we had originally. It's literally just doing nothing, directly assigning it, right? We define the bool on top and put the functions together to make it a meter. And I will save it and come back here. Now I'm going to select my player and I'm going to assign 3 elements. So first, second, and third. Okay, so the head constraint doesn't need to be assigned in there. I'll save the project and hit play and see what happens. So all these spine constraints, they are going to be correctly assigned with their correct offsets, I'm sure. As you will have a look, their offsets are 0 at the moment because we're clipped. Now that works. Let's go to the next task, which is setting both position and rotation together, because assigning one by one is not a good thing. I think it is more optimized. Actually, read it somewhere. So we'll delete the camel target rotation, which is no longer used. And I'm going to find wherever we're using the position and if we have a rotation assigned at the same point. Well, right in the first place, the camera holder. There's where it's used. So now we're just going to pass in the same thing that we're doing, but just using the function instead. Perfect. So that's done. More areas where we can use this. Note here. They're just positions, not the rotation actually. And you don't have set position because there is no point in that. Okay, so here we're assigning a lot of position and rotation together. So use the transform.set position and rotation and give them the correct position and rotation. And again, right here, again, we're gonna correctly assign it using the set position and rotation and pass in rifle holder's rotation and position. And then over here again, we'll assign the pistol holder position and rotation. Remove that common code which was no longer used, the older one. And I think that's it. So just 2 areas, maybe 3. Now to the next thing, which is, well, hash animator strings before using, and use the hash values to set the parameters. Now, this is actually a much optimized version of the strings because Unity has to hash the strings that you give it, and that's what we will do for it beforehand, one time. So I'm going to define the ints, as that's what the hashes are for each of my fields. The walk or run, the weapon type, and the round jump. So we got all of them, and now I'm going to just put them all here. Just clean it up. And I'm going to equal them to the animator, which is the class, and it provides us a static function, which is a string to hash. And you pass in the actual names that we have specified. All right. Now, where we're using these, that's where we're the animator, where we're using it. That's where we're going to replace it with the hash, because now we're going to pass in an int, and not the string. So just going to add the hash in front of the name, because that's how I named them. Okay, that's it. So all the hashes have been correctly put. And now let's give it a test and see if our animator is able to give our person the locomotion and everything else as well. So as you can see, we got these new hash IDs which are generated. And look, everything is working. We can run around, move around. So that means that our code is not faulting. Back to the normal selector, and let's move to the next task, which is disable the follow pause on interact pointer and create a new follower for it, which is because of the fact that now, because beforehand we made this interact pointer so that when we are clicked also we can interact with something where our camera was previously pointed, but now it doesn't work because this script positions it to the clipped area, which isn't really exactly what we wanted. So what I'm going to do is I'm going to disable it. And before disabling it, I was supposed to enable it and start, as you can see, and then disable it. So we get the actual position, and now we just paste that position directly on it. I will create a new script because we still need to follow the x-axis. So to do that, I'm going to create a new script for transform follow position with axis. So we'll have a transform for the target. The bool, if we want x to be followed, we have a y to be followed or the z to be followed. And then we'll also have an offset for the position, which is by default 0. Then we are going to assign it to this in a while. And we'll also add a bool which is take initial position into account, which is by default, well, default, I think. And then if we're taking initial position into account, we need also vector 3 for the initial position. We're going to simply use the initial position and assign it to the local position, which wasn't. Then in the update, we're going to just set the local position of this to the target position, which is in the vector 3, which is going to be updated one by one without using the new keyword. So the x, we'll check if x, then we want to do target position of x, otherwise the initial position on for z and every other same thing. But I'm just going to update it so that the offset is also taken into account if we enable x and y and z. So that's it, very simple. The position offset also just added to that after everything's done. So as you can see, now we just have the x-axis being followed. Actually, we're supposed to select local position. So I'm going to rename this class as well, just after testing. So now, as you can see, I'm going to enable the take into position initial so that it works. And yes, it does. And I'm going to set that to default by true because I think it's a good feature. And then I'm going to rename the class to be local position, not just the position. It's only the local position. All right, the next thing is to clean up interaction code and streamline the interaction system. Currently, you'll see our interaction function is big, well, very hard-coded stuff, so which is not good. We'll just clean that up. And the header interact UI state also needs to be better. So as you can see, a simple 2 lines instead of that many lines. Now I'm just going to fix the actual big function, which was on the main page. So that's going to be fixed like this. We'll have a long if statement which checks everything out with the most simplest at the start, which is a bool check. Now if all of this is true, then you want to check if the interactable is interactable. If it's not interactable, then we just want to return. And then we'll define that inside the iInteractable interface so that we can update our code that is using that interface in a bit. Now I'm going to use else so that we can pass in handle interact UI state false and UI state true with interactable. Then after that, we check is the input even triggered. If that's triggered, then we just want to interact while passing this again. This code can be removed, and we go to the weapon base and implement the function that we just created for the interactable interface. So we'll define a bool can interact, and we'll return. We'll just get the player controller reference first. We'll return player controller. The current weapon is not equal to this. So if that is so, then we want to return true. And also the current weapon, the weapon type is equal to this. Then we want to return true. Otherwise, if both of these statements are true, then all things want to return true. Otherwise, false. So that's exactly what I want. For the ammo and the gate scripts, they will just return true by default as they don't have any special behavior yet. So I'm going to save and come back here. And let's have a test. So I can interact with these weapons. Yes. And this one as well. But if I try to go over here, I do not get anything. Like, even if I put my exact fire point there, which is exactly what I wanted. Now, if you put the arrow 18 and you take that, you can keep swapping with these, which works. Now, adding update intervals for weapon clipping and interactive detection. This will help our code to become less heavy, meaning we'll add some intervals of the update, meaning how many frames should we, I guess, skip between when to actually perform the checks. So I'm going to do this for the weapon clip and the interactable interval. The interval for interactable I will set to 30, and for the detect weapon clip I'll set to 15. I'm going to define a new section for this, the main section, where we can add any main stuff or general stuff anyway. Now I'm going to comment out the weapon clipping function that we recently just updated, and I'm going to define a new bool for the clipped state. to set defaults by default. And then we're going to have a detect weapon clip function, which is going to actually detect the weapon clip. And this is the one that's going to be called every how many frames you select, right? We'll remove the update stuff and just put the calculation stuff where we check everything and assign states. And then set spine constraint offsets here in this function and everything here. Then I'm gonna, oh well, it looked like there was giving an error, but now it's not giving, so let's go here. Okay, so I'm going to comment out the interaction function and make a new function for detecting. So the detect interactable will do pretty much all of the stuff that the actual function would do, but it will not check for the input, and the input will be checked by the actual interact input check, which is going to be called every frame. So we'll check if we are in interaction range and we have the input that is played. So if that is triggered, then we want to do, well, we need a reference for the interactable as well, which is also going to be a variable, a field. And we'll check, we'll actually just interact with it, right? So passing in this as the controller. I'm going to comment out the two functions which we deleted or commented out. And I'm going to check if the time dot frame count. And I'm going to use this, well, percentage operator. And we're going to check if detect weapon clip interval. Put that down there and detect the weapon clip if that is so. Similarly for the interactable also, just use its interval instead. And again, check if it's 0 and then do the detect interactable. Okay, and then update everything just like normal. In the frame, we need to do the interaction input check and the update of the weapon stuff, clipping stuff, right? So now, as you can see, we have got everything working. And if I move over here and I try to swap one, there might be a small delay, but it has actually nicely improved a few things, which is that the performance will be better. I know the frames seem to not change, but I think that's due to the fact that my models are not very optimized. Anyway, let's just clear and clean up some stuff. Remove the code that we're not using. Rename everything with underscore, which is private, that we just defined, and give them the correct sections, like right here. I'll put that bool, and I'm going to actually rename it so that it's just used by this. It's a detection, not the actual one. Then remove the interaction one and make that an underscore detect interactable detected one. Then we will just put this as well in the correct position, which is inside the interactable area, interaction area. And yep, that's it. So see you in the next one. Make sure to subscribe and like.